Alright everybody, today we're going to be talking about 4.4, which includes two new congruency theorems for triangles, side angle side, and one called hypotenuse leg, so SAS and HL. Starting with SAS, side angle side congruence postulate. As it says here, if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. A few terms to identify here. First of all, this idea of the included angle. An angle is included when it's the angle that's between two sides. So if we look at side SR right here and side RT, the included angle would be angle R, because angle R is in between SR and RT. It's that angle right there. So basically what you need to use side angle side is you need an included angle and the two sides that are around the included angle to be congruent between two triangles. So, because SR, angle R, and RT are congruent to VU, U, and UW, these two triangles are congruent by side angle side. Notice that if you start at one of the sides, like SR, the order that you encounter things in is a side, then an angle, then a side. SR, followed by R, followed by RT. So that's how side angle side works. So let's say that we wanted to do a proof that used side angle side. Well, remember, what that means is we're going to need to show that there is a side that's congruent, an angle that's congruent, and then another side. So we're given some information on this one. We know that BC is congruent to AD. They've already marked this for us. And we know that BC is parallel to, remember that's what those mean, and these arrows here, parallel to AD. So, what we're going to do then is we're going to start showing that certain things are congruent. Easiest one to start with, then, is that BC and DA are congruent. How do we know they're congruent? Well, this is one of those parts where that information was given to us. So, what's our reason? Simply given. So, that's one part out of the bag. We have one of our sides. Another side that we know has to be congruent, and this was something that we saw in our proof video, is that AC is congruent to itself. Now, why the heck would we want to even say something like that? Well, if you look at the picture, we see that AC is involved in both of the triangles. And what that means is that AC has the same length in this triangle as it does in this triangle. So, AC is something that we can use to help show that the two triangles are congruent. And again, this one, when you use the same side, is called reflexive property. So, in order for us to use side angle side, what we need now is an angle that's the same between them. And this is where the parallel lines come into play. Because, if you remember, AC is kind of acting like a transversal for these parallel lines. And what that means is we have alternate interior angles that are forming around here. So, what we have is this angle and this angle. Those two angles are alternate interior angles. So, what that means is if we compare angle, we're going to compare two angles. So, we have angle CAD, and we have angle ACB. So comparing those, what we can say is that they're congruent. And what's the reason? Well, we ended up using alternate interior angle theorem. So, finally, we're able to make our proof statement, and we can say triangle ABC, we'll leave room for the congruency, is congruent to triangle CDA by, and this is going to be a step that you always do at the end of these, SAS. So once you make that statement, that's the end of your proof. People usually end proofs by putting a little symbol at the end. A really common one is to put a square that's filled in. I've seen smiley faces used, so you could do a number of things, but you just want to put a symbol that recognizes that your proof is done, and there it is. So proof is done. Alright, so that's how side angle side works. Next theorem is hypotenuse leg, and it's very self-descriptive. You need right triangles for this one. So, if the hypotenuse and leg of a right triangle are congruent to the hypotenuse of a leg and a leg of a second right triangle, then the two triangles are congruent. So, in a right triangle, if you have the two hypotenuses the same length and two of the legs the same length, then the triangles have to be congruent. So let's look at this one. Choose a postulate or theorem. You are making a canvas sign to hang on the triangular wall over the door of a barn, shown in the picture. You think that you can use two identical triangle sheets of canvas. You know that line RP, this symbol means is perpendicular to QS, so that means that we're forming 90-degree angles here at this intersection, as is said here. And we know that PQ is congruent to PS. What postulate or theorem can you use to conclude that triangle PQR is congruent to PSR? Well, we know this is a 90-degree angle. Since there are 180-degree angles along here, we know this is also going to be a 90-degree angle. So, we have a side and an angle that's the same, and it is a right triangle, so HL may come into play here. But, do we really have a way to say that RQ and RS are congruent? And the answer to that is right now we really don't have a way to say that. We don't know for sure that they're the same length. But we do know that RP is the same length between both triangles. So, reflexive property says that this is the same between both of them. And now if you look, what we have is we have a side, the included angle, and the other side that makes it the included angle. We have side, angle, side, side, angle, side. So, we wouldn't be able to use HL here even though it's a right triangle. We would need to use side, angle, side. And that's really all I have for you right now for these notes. So, hopefully you found this helpful. See you in the next video.